Hello, everybody. Hello, Kalki Oliveira. If you're new to this, okay. What do I even want to do today?
create pixel art. So these are the three creating a background with some mountains and a sky. So these are the three things that we'll be going over how to create. We'll be going over a wide range of different tools and methods in Photoshop, looking at how we can use the paintbrush, the eraser, swatches, selection, layers, etc. Okay, we'll go over a wide range of tools that you need to know in order to create pixel art. There is one prerequisite for this course, and that is you need to install and open Photoshop, okay? And that is where the course will begin from. We're not going to go over the installation of Photoshop, as it does vary depending on which version you have and when you're watching this course. So and it's fairly straightforward. When you get Photoshop, it's a fairly straightforward process to install and open up. And once you open up Photoshop, that is where we'll begin with lesson 1. Zenva is an online learning academy with over 1 million students. We feature a wide range of courses for people who are just starting out or for people who just want to learn something new. The courses are also very versatile, allowing you to learn in really whatever way you want. You can choose to view the online video tutorials. Hey everyone, and welcome. In this lesson, we are going to be going over how we can set up our Photoshop document to begin starting with our pixel art creation. So, as you can see here,
So the new Godot 4 alpha version just dropped, and with it we can play with the new tile map we all awaited. And you guys wanted a tutorial on how to use that thing.
Hey guys, if you're new to the stream, I'm trying to develop like a game that you would use as scenery in a in the corner of your stream or something like that. So it's not like a game where like you're using input devices, but more like scenery or a screensaver kind of thing. And right now I have kind of a basic. This is going to be a bedroom. I need to put like a bed in here and stuff, but I'm learning how to add things and get things to look good and stuff like that. So yeah, feel free to follow if you find that interesting. If you don't, I totally understand. If you have any questions, just throw them in the chat, and I'll respond to them as soon as I can. And I'm trying to remember how to use the tile map feature because I forgot.
So here it is. Let's make a little scene using this tileset you can get for free on itch.io. We add a tile map to the scene and add a tileset to the tile map. Here we can set the size of the individual tiles, 16x16 in our case. We get greeted with the message, this tilemap's tileset has no source configured. Added a tileset resource to add one. And I will not lie, I searched up here first, because I think this is the tileset resource. But what this message means is this tab all the way down here. It also says tileset and only is visible when we select the tile map on the top left. So we click that. We can drag our image in and it will automatically be split into tiles. It's so smart, it even leaves empty tiles out. The image is now called a tile atlas. We can delete it with this trash can. Pressing delete will ask to delete the whole tile map currently. To delete tiles, use the eraser. Now we can make a single large tile for the tree by deactivating the eraser and holding shift while dragging over the tree's tiles. We can also change tiles manually by clicking the cursor icon and then on the tile. Notice these little circles? You can use them to expand the tile. Now let's map a little. Go to the tile map tab. We can select a bunch of tiles down here and just start mapping. We can paint tile by tile, hold shift to draw lines, and even hold shift and control to draw a rectangle. We can also switch between these tools with these buttons or the keys D, L and R. There's also a fill tool and a picker in the bar, or we press Ctrl to pick the tile. When we select multiple tiles, by drawing a rectangle in the lower window or by pressing shift, we can place many of these tile arrangements at once. We can also enable place random tile, so we get a random tile from our selection. If we enable scatter, sometimes no tile is placed. This is great to quickly decorate larger areas. To move tiles, draw a rect with the selection tool and then just drag the selected tiles. Called a tile atlas. We can delete it with this trash can. Pressing delete will ask to delete the whole tile map currently. To delete tiles, use the eraser. Now we can make a single large tile for the tree by deactivating the eraser. This tab all the way down here. It also says tileset and only is visible when we select the tile map on the top left. So we click that. We can drag our image in and it will automatically be split into tiles. It's so smart, it even leaves empty tiles out. out. The image is now called a tile atlas. We can delete it with this trash can. Pressing delete will ask to delete the whole tile map currently. To delete tiles, use the eraser. Now we can make a single large tile for the tree by deactivating the eraser and holding shift while dragging over the tree's tiles. We can also change tiles manually by clicking the cursor icon and then on the tile. Notice these little circles? You can use them to expand the tile. Now let's map a little. Go to the tile map tab. We can select a bunch of tiles down here and just start mapping. We can paint tile by tile, hold shift to draw lines,
Hello, welcome to the stream. Um, what I'm trying to do is kind of create like a screensaver kind of thing for streamers to use where they can have a cat moving around the space. Um, Does this interest you? I'm trying to learn how to do it with Godot engine, or Godot engine. Yeah, feel free to follow if this interests you. Thanks for stopping by.
So you want a donut, but you don't live next to... Soap, you want a donut, but it's illegal where you live on Mars. Well, maybe you should join the rest of us on the sun right now because everything is so hot. Hey guys, that's my Kai. I'm Kai, and today back once again taking a look at how I made this cute, extremely simple pixel art sprite in a sprite here today. So we're gonna break this down. It is probably the most simple sprite you could possibly ever make, other than like, I don't know, a stick figure. I don't know. We'll see. But so the first thing I want to have you notice is that there's literally only 6 different little men here. So we have these first 2 over here on the left hand side. We have both of these guys, and then we have 2 over here, which is from the back here, and then we have these 2, which is from a side. So essentially, what you'll do is, if you're using this for a game or whatever you're using this for, this would be obviously the frontwards walking sprite. This would be the walking sprite from, looking at the back of this character, and this would be to the right. Or if I was to flip this, this would be to the left. So you can see that works the same way. But what we'll do now is we'll take a look at exactly how simple these really are. So we're in a 16 by 16 canvas. Actually, technically I'm in a 16 by 96 canvas. So each one of these little gray squares that we see here is 16 by 16. So this is 16 down and 16 across, just like that. So the important thing is to keep these all consistent. So we need to have 6 16 by 16 squares to start off with. And then what I did was I went ahead and I drew this guy first. He's literally just basically a cube that's rounded edges, and then he has little feet on the bottom. Now I want to keep this super simple, so he has a little face in the middle, and then there's one color to shade that base color. So we have the base color. The base color for the skin is this bad boy right here, this color like that, and then I used one singular other color to use as the shadow for that. So that's the shadow that's coming on top of the little helmet, or whatever is the top of this guy's body, because it literally just is a head. He's literally just a walking head. He's a head with legs. And then we have the eyes, which is just black, which is the same color as the line art, and we have white for the whites of the eyes. And then we have the blue, the base blue, and then we have one singular color to shade the darker colors for the blue. Now I use this a lot here on the feet, so I give the feet a bunch of shape. So if I didn't have this color down there, it would look like that, which is like the old school Mega Man. It looks kind of like the original Mega Man type beat. But having this makes it like this little part right here. It's like maybe a bit further back, and then his toes kind of have a little bit of light on them, which looks kind of cool there. I like that a lot. And then what I did was I just took that same sprite and I just hit M to drag a box over top of this, hit Control C and Control V, moved it on over, and you can see all I did was I took his left foot, I selected this whole thing right here, and then just made it bigger. I just scaled it up like that, and that's literally all that I did. And then I also made this one, I pulled this one in by a couple. So I pulled his right foot inwards like that, and then I made his other foot bigger, and that's how we got this right over here. And then all we have to do, if we want to make it look like he's walking, in your animation, all you need to do is just take this bad boy and then flip him. And you see when I flip him horizontally, which is the shortcut is Shift H. So we do that real quick. Shift H. You can see it looks like he's walking. So super simple. Walk cycle, literally the easiest thing you can ever possibly do. It looks cute and it works. There you go. So that's nice. And the same thing for this bad boy over here, which is just from the behind. So I just really got rid of all of his characteristics. So all of his face, all of his eyes, those things are gone. Okay, he has no more face. That's unfortunate. I don't know what happened, but he needs to get his money back. So now we only have him from behind, as you can see, and then we have everything's in shadow on the legs there. And then for the walk cycle, let me actually put that back. There we go. For the walk cycle, all I did was get rid of this leg on the left-hand side, make it look like he's pulling it forward. And then once again, walk cycle, same thing, super simple, literally as simple as it can get. Literally, it could not be something more simple than this. Walk cycle from behind. There you go. And then we have these ones over here, which these are a little bit more difficult, obviously, because we have to add the face back in on a different angle. So I have this one from the side, which again, I've just taken this default little guy right here, and then copy pasted him over this side, and then I changed it up a little bit. Added a couple of things. We have this nice little cutout piece here for his helmet, and then I have, his face from the side view. And then we have the leg. Well, we only have one leg on this side because it's, the side of his body. We only have one leg there, which is super simple. And then for this took a little bit of finessing, but I went ahead and I made it look like he's like doing a little run, a cute little run thing. So that's really, really nice. Now, the issue with this is that you cannot just flip these ones back and forth to get the walk cycle to work properly. So you'd have to go and toggle back and forth between this. Okay, I can't draw. Between this and between this. Now you could
So I'm in Go.4, and as you can see, this path updates 10 times every single second to find the best possible path to get to our player, no matter if we're behind obstacles or anything, and it does not get stuck on walls, it will slide across it. But before we get started, I just want to ask if you can go down below, hit that subscribe button, drop a like on this video to help YouTube push this to any aspiring game developers who are trying to learn to make their own Go.games games and need pathfinding for those. Go.4 makes this pathfinding super easy, so let's just get started and let's create this pathfinding here in Go.4. Okay, so to create pathfinding in Go.4, so what do we have in this game already? We have a couple of starter items, which we have a camera 2D just so we can zoom in close. We have a player, which has some basic movement, and our player is just a sprite and a collision shape. And we have some very basic movement. So if you want to copy this down for your player, if you don't already have a player, but for pathfinding, you probably already have a player and you just need help on the pathfinding part. So we have a simple player, and then we have a tile map, which as of now, our tile map has no collisions or navigation 2D or anything. And we need to go and we need to add navigation 2D to this tile map because that's going to be important to pathfinding for our pathfinding node that can help us, move around. So let's think about this. We want collision shape on all of these darker squares, right? These are all collisions. So we're going to make this all with collision 2D or with collisions. And then on this lighter gray, which these are their own tiles. I know they look like the background, but they're not. I'm actually going to add a color rect real quick just so we can kind of see the difference. So we can see it behind. As you can see, these are their own tiles. It's just like, if you see this right here, this is my tile set. It is a, it's almost the same color as the background, but it is its own tile. So if we go to our tile map, this is the first thing. We need to add navigation and we need to add collision. So to do this, we need to go to our tile map over here in the inspector, our physics layer. We're going to add a physics layer, and then we're going to go to our navigation layer, and we're going to click add element, and we're going to add a navigation layer. Now if we open up our window down here and we click on tile set, we can go to whatever tile set you have. For me, it's just 2 tiles in here, but we can go to paint, select the property, physics layer, and we can just click on this. Now the darker square does have a physics layer, so it's gonna have a collision. And then if we go to our navigation layer and then we add navigation to just this one, you don't want it on this one, you just want it on the ones that you want your enemy to be. go down below, hit that subscribe button, drop a like on this video to help YouTube push this to any aspiring game developers who are trying to learn to make their own Godot games and need pathfinding for those. Godot 4 makes this pathfinding super easy, so let's just get started and let's create this pathfinding here in Godot 4. Okay, so to create pathfinding in Godot, so what we have in this game already, we have a couple of starter items, which we have a camera 2D just so we can zoom in close. We have a player, which has some basic movement, and our player is just a sprite and a collision sheet.
Everybody, I'll be right back. And we're back.
So I'm in Go.4, and as you can see, and then we're going to go to our navigation layer, and we're going to click add element, and we're going to add a navigation layer. Now if we a basic enemy, just like our player, a sprite 2D, we're also going to have a collision shape, and we're also going to need some. And then if we go to our navigation layer, and then we add navigation to just this one, you don't want it on this one, you just want it on the ones that you want your enemy to be able to go on top of. So like the ground, this is like the wall, this is like the ground, right? So we'll do that, we'll save, and then now if we play the game, we should have collision, and you have navigation 2D on the bottom, but you cannot see that, right now. But it will show in just a minute when we have our enemy created. Okay, so now for our enemy, so we can have our pathfinding layer, and we can just click on this. Now the darker square does have a physics layer, so it's gonna have a collision. And then if we go to our navigation layer, and then we add navigation to just this one, you don't want it on this one, you just want it on the ones that you want your enemy to be able to go on top of. So like the ground, this is like the wall, this is like the ground, right? So we'll do that, we'll save, and then now if we play the game, we should have collision, and you have navigation 2D on the bottom, but you cannot see that, right now. But it will show in just a minute.
Welcome back everyone. In this lesson, we are going to be setting up our enemy scene. Now, the enemy scene... Welcome back everyone. In this lesson, we are going to be setting up our enemy scene. Now, the enemy scene is basically going to be similar to our player in the sense that it's going to be an object in our world, and they are going to be moving from one position to another, and if they get hit by the player, then that's game over. So to begin, what we are going to do is create a brand new node here, okay, and this is going to be of type Area 2D. Now, an Area 2D is basically a node which can detect collisions or detect when another collider has passed through itself, and then we can run the respective code for whatever we want to do. So we've got our Area 2D, let's rename this to be our enemy. We then need to give our enemy a visual so we can actually see where they are. So we're going to open up our sprites folder, characters, and I am going to use this bat character right here so we can drag them in, make them a child of enemy, rename that node to be sprite, and set its transform position to be 0 on the X and 0 on the Y. Now with our enemy here, we can move this over here just so it's out of the way of our player. And what we are then going to do is attach a collision shape, because in order to detect collisions, we need a collision shape. So we're going to go add child node, collision shape 2D. This is going to be a circle shape. Okay, and we can then change the size of that. So I'm just going to make it a bit smaller than the sprite so our player can pass by just. And there we go, that's all we need for our enemy node. Now, we need to create a script. So I'm going to go over to the inspector. I'm going to create a brand new script called enemy.gd. Make sure it inherits Area 2D here. Click create. First of all, let's go ahead and add in some variables. So our first variable is going to be our move speed, and this is basically going to be how fast this enemy is going to be moving. It's going to be of type float, and it is going to be equal to, let's just say, 30 by default. Okay, so 30 pixels per second. We then want to have another variable for our move direction, and this is going to be type vector2. Now, our move direction is going to basically be in what direction and how far do we want this enemy to move before returning to its original position. Because if we go back into 2D mode here, I'll show you what I mean. Basically, with our enemy, it's going to have a starting position, so let's just say it's here, and then we're going to have a move direction. Now, let's just say our move direction is up by about 100 pixels, okay? It's going to be up around here. So what's going to happen is at the start, it's going to move along that until it reaches its start position plus move direction, and then return to start position, then along that move direction again, then back to start position, okay? And we can basically have that wherever we wish. Now, these values are of course going to be different for each instance of our enemy. You know, one enemy we might want to move faster than another, we might want to have a different move direction from one another. So in order to modify these values in the inspector, we need to export them. And to do that, we just need to add in the export, like so, in front of each of these variables. And now, if we save that and look in the inspector, you should see we have a move speed and a move direction property. Now, along with these variables, we also need a variable for our start position, which is going to be of type vector2. We're not going to be exporting this since we're going to be modifying it in code. Same thing for our target position, okay? So, our start position is going to basically be the starting position of the enemy, and the target position is going to be where the enemy is going to currently be moving towards. So down here in the ready function, which gets called right at the start of the game, we are going to set our start position by going start pos equals global position, and then we also want to set our target position, so target position to be equal to our start pos plus our move direction, okay? Like so. Now that we have this set up, what we can do is down here in the process function, we can move towards our target position every frame because the process function gets called on a frame by frame basis. So to move towards our target position, we are going to go global position equals global position dot move toward. Now we want to move toward our target position at a rate, so we can go comma, at a rate of our move. so target position, to be equal to our start pos plus our move direction, okay? Like so. Now that we have this set up, what we can do is down here in the process function, we can move towards our target position every frame because the process function gets called on a frame by frame basis. So to move towards our target position, we are going to go global position equals global position dot move toward. Now we want to move toward our target position at a rate, so we can go comma, at a rate of our move speed multiplied by delta. Now the reason why we are multiplying by delta is because since this function gets called every single frame, that means that we are moving towards our target at move speed, okay? And if we didn't have the delta here, that means we would be moving towards our target at 30 pixels per frame. And multiplying that by delta basically converts that into 30 pixels per second. And since process can fluctuate, from maybe 10 FPS all the way up to a couple hundred FPS, it can be all over the place. If you're running on a slower machine, then the enemy would move slower. If you're running on a faster machine, the enemy will move faster. Multiplying by delta just makes it consistent. So we have that. Now what we need to do is we need to go ahead and basically check to see if we have reached our target position. So if global position is equal to our target position, then what we want to do is basically switch them around. So we can then check if global position equals our start position, then we want to set our target position to be equal to our start position plus move direction. Otherwise, what we want to do is we want to set our target position to be equal to our start position. Okay, now we have a couple of statements here and it might be a bit confusing, but pretty much what we are doing here is making it so that once we have arrived at our target position, we're going to check to see if, first of all, is this our original start position? If so, then we want to move along our move direction. Otherwise, if we are at the end of our move direction, we want to move back to our start position. And what this means is that we are basically going to be moving back and forth between those 2 points. So let's save this. Let's go back into our scene here and we'll just set up a nice simple enemy movement. So we have our enemy here, move direction, I'm going to set the Y to be, we'll go negative 50, so that basically means our enemy is going to be moving up 50 pixels, then back down to where it started. So let's press play and see if it works. And as you can see, our enemy moves up 50 pixels, and then back down to its start position, then back up 50 pixels, then back down to its start position, okay? And that is just going to be looping over and over. But as you can see, our enemy can hit us and it does nothing. So what we need to do is make it so that when the enemy collides with our player, it is going to call that game over function. Now to do this, we first of all want to select our player. We want to go into where we have the node window here next to inspector, select groups, and we want to add our player to a new group. Now, a group is basically like tagging the object, and this just allows us to quickly identify, what sort of node this is. So I'm going to add player right here, click add, and now our player node has the player group. So what we can do with this is if we go back into our script, select our enemy script, we need a way of detecting when a collision has happened, when the enemy has entered another body. Now to do that, we can select our enemy node here. We can then go over to the node window once more, but select signals. And in signals here, we have a bunch of them. And a signal is basically a function call for when a certain event happens. And we want to go over to where we have the body entered right here. So we want to double click on that, select our enemy, click connect, and we should have
Welcome back to the channel, and today I'm going to be So I'm in Godot 4, and as you can see, this path updates 10 times every single second to find the best possible path to get to our player, no matter if we're behind obstacles or anything, and it does not get stuck on walls, it will slide across it. But before we get started, I just want to ask if you can go down below, hit that subscribe button, drop a like on this video to help YouTube push this to any aspiring game developers who are trying to learn to make their own Godot games and need pathfinding for those. Godot 4 makes this pathfinding super easy, so let's just get started and let's create this pathfinding here in Godot 4. Okay, so to create pathfinding in Godot, so what do we have in this game already? We have a couple of starter items, which we have a camera 2D just so we can zoom in close. We have a player, which has some basic movement, and our player is just a sprite and a collision shape. And we have some very basic movement. So if you want to copy this down for your player, if you don't already have a player, but
All right, I think that's where we're going to stop it for today. I'm going to dig further into the pathfinding stuff next session. Thanks everybody for tuning in.